Hi and welcome back. Today I'm going to be going over the entire forge welding process. Now I have to tell you, when I started blacksmithing, forge welding gave me nothing but trouble. Sometimes it would work, sometimes I couldn't get it to work for anything. I really just didn't have a clear understanding of what I needed to achieve to get a good forge weld. So long story short, I basically got so frustrated that I just convinced myself that you just couldn't weld mild steel the same way you could wrought iron, and I basically just forgot about the whole process for about 20 years. And not long ago, a friend of mine came over and wanted me to show him how to forge weld, so I was feeling kind of confident, I guess. I said, sure, I'll show you how to do it. And totally embarrassed myself. Everything that could go wrong did go wrong. It was just a total failure, probably some of the worst forge welds I'd ever done in my life. So I said, that's it, I'm not doing anything else until I figure this out. So I basically started from scratch, threw away all the advice I had gotten from different people. Some were well-intentioned but really didn't know what they were talking about. Some people just flat out lied to me. All the sketchy things that you get out of books and everything. I basically just started from scratch and said, okay, what has to happen? So this video is basically what I came up with. The first thing you're going to need is a well-designed forge if you hope to have any kind of consistent results with forge welding. This is a fairly good design for a fire pot, and it was probably available right up until the Second World War. It's about 10 inches square and roughly 5 inches deep. There is no flat bottom to this fire pot. All four sides slope towards the middle. This particular design has an eccentric tumbler that rotates around and breaks up any ash or clinkers that are shutting down the airflow to the fire. The air is supplied to the fire pot by a 3-inch pipe. This supplies the large volume of air that you need to feed a big fire, but it doesn't supply it as a high pressure blast, which tends to burn through the center of the fire very quickly. Here I have examples of the three things you're going to find in the fire. The first thing, of course, is the raw coal. Raw coal always stays at the outside edge of the fire until it gets burned into coke. Coke is raw coal with all the impurities burnt out of it. As coal turns into coke, it tends to stick into larger clumps that are about the consistency of dense styrofoam. The main part of the fire is formed out of coke because it's very clean and it burns very hot. The last thing you're going to find in a fire is clinkers. Clinkers are all the impurities that have melted together into a lump. Clinkers will form in any fire, but they really form quickly when you're forge welding because of all the flux that's dripping off the bar. So you need to clear these out of the fire on a regular basis. They don't burn, so they will reduce the intensity of the fire, and a lot of people believe that they will contaminate a weld. Okay, I'm ready to start putting the fire together. Now, when you're forge welding, you need a very deep fire. And that's kind of hard to achieve in a small forge like I have here. So what I do is I place a brick on each side of the fire pot, and that allows me to build a higher bed of coals without it spreading out too far and overflowing over the edges of my forge. Now I'm going to leave this brick out today just because it'll make it hard for you to see anything that's going on in here. So I'm going to take the coke, throw it into the center of the fire, and I'm going to use that to start my fire. Now you can use anything you want to start the fire. Most people use newspapers or bits of firewood, little bits of kindling. I usually use this liquid kindling. Works pretty good. Once I get the coals hot enough with the torch, and I can remove the torch for a second and the coals still stay lit, I start giving it a little bit of air. The coals, even though it's coke, it won't stay lit if it isn't up to a certain temperature. So I'm just leaving the heat on, giving it a little bit of air. take and I start pushing the coals into the center. Okay, so I have the fire going pretty well now, but it's still basically level with the edges of the fire pot, so that isn't quite deep enough for what we need over forge welding. You want to have a really good bed of coals underneath the steel. So now it's time to start adding some raw coal to the fire. Now I'm going to keep this coal out to the sides. The center is for coke, the outside is for coal. So I'm going to be pushing the outside in as the coal turns to coke, and I need it in the center of the fire. But for now I'm just going to add another couple of shovelfuls of coal just to build it up to a nice real deep bed. Okay, so now I have the center of the fire going pretty well. You can see that the heat is coming out to the sides. It's starting to burn off all the impurities from the coal and creating a lot of smoke. So I'm going to control that by just sprinkling water around the outside, wetting down those coals. Because right now these coals aren't really working for me. They're just there as a retaining wall to make sure that I can build the fire up high enough. So I'm not really ready for them to be part of the fire just yet. Getting back to starting the fire, the main reason I use propane over wood is strictly for convenience and safety. Wood does have the advantage of providing a really good concentration of heat that you need to get the fire going, but I just don't like having all that combustible material kicking around the shop. So as the fire is burning, I'm always using my poker to push the fire into the sides. I don't go from the outside and push in, because that'll push in raw coal. I go halfway in between, and I push, and I make sure that the fire is solid. You don't want the fire to burn hollow while you're taking a welding heat, so you need to take a few seconds each heat to make sure that all the air pockets have been pushed out of the fire. And that's basically my fire. I have a nice bed of coals, a lot of material on the outside that's getting ready to be pushed into the center of the fire. I can get a really hot fire going, so I'm ready to start working the weld. Prior to this heat, I took a couple of heats to upset the bar slightly, and now I'm just forging a basic scarf joint. There's a lot of different theories about how scarf joints should be made, but I've always used a pretty basic taper. That part of the process is all personal preference. Concentrate on getting the bars to stick first, and then you can fine-tune all that other stuff later. Now here's what the fire looked like when I was done forging the scarf joints. There's a solid ring of coke around the outside of the fire, but the center of the fire is actually dropped about 4 inches. There isn't a lot of perspective in this shot, but I have the entire tip of my poker in the fire and I'm not touching any coals. If I took another heat without fixing this fire, the bottom would drop out and I'd be getting cold air hitting my steel. Once the fire's been going for about 20 minutes, you need to start checking for clinkers. And you definitely need to check the fire before any welding heat. I use a thin poker like this to rake through the fire. Clinkers are always kind of ragged, so they hook onto the poker and get dragged to the surface. They tend to cool very quickly, and they do clink when you hit them with the poker. Now that the fire is clean, I'll take a few seconds to tighten up the center of the fire once again, and then I'm ready to put the metal in the fire. In this heat I'm getting the bars hot so I can apply the flux to the surface. Once I get the bars to an orange heat, I'll be taking a wire brush to remove any scale off the surface of the bars, and then I'll be applying the flux. The flux I use is just regular 20 mule team borax that you get at the grocery store. I just sprinkle it on the surface until it melts into a thick coating. Borax works well for preventing scale from forming on the bar, but it won't dissolve a heavy buildup of scale. Now the bars are in the fire for a welding heat. I have the bars sitting close to the top of the fire because I want to show how they look when they reach a welding heat, but normally I would have them buried in the fire and totally surrounded by coals. I start the heat by supplying the fire with a lot of air. This does create an oxidizing fire, but the bars are nowhere near welding heat and the flux is still very thick and pasty at this temperature. I need the extra air at this stage to create a very hot fire around the bars. Once I have the fire glowing like a furnace, I can really throttle back on the blower and just supply enough air to keep the fire going. This produces the reducing environment that you need to bring the bars to a welding heat. You can see how the tips of the bars that are in the fire look like they're covered in melted butter, but the ends of the bars that are exposed to the air are starting to scale up. Now watch this. I'm going to apply some flux to the sections of the bars that are starting to scale up. You can see how the flux just did not affect it at all. Now if that was allowed to form on the ends of the bars, this weld wouldn't take. When you pull the bars from the fire, you're going to want the entire weld area to look like it's just coated in melted butter. So I'm going to take these bars out, clean them off, and reflux them, and do the heat the way I normally would before I go on to the next step. And now, with all that being said, it really is just a matter of taking them out of the fire and sticking them together. I'm only sticking the one scarf with this heat. You can see when I turn the bar over that the other scarf has already started to scale up. So I'm going to wire brush that scarf and reflux it before returning it to the fire. And now that I have the second scarf welded in, I'm going to take a couple more heats to finish the weld. I try not to hammer too much with each heat. I'm trying to keep the core temperature as hot as possible, so I hammer quickly, return it to the fire, and take another heat. The additional heats at a higher temperature really help to strengthen the weld. So there you have it. After 30 years of frustrations, I think I've finally managed to put a lot of those problems to rest, and I hope it's answered some of your questions as well. We'll see you next time.